I'm Logan Crawford, and right now on the Spotlight Network, we're unraveling the mysteries of the universe with a compelling book, an amazing book. It is called A New Light on the Expanding Universe. It's written by a terrific author by the name of Hardison. This groundbreaking book challenges long-standing scientific theories, proposing a bold rethinking of Einstein's concepts of light, relativity, and the nature of the universe's expansion. With over 6 decades of engineering expertise and a passion for questioning conventional wisdom, Les offers a compelling alternative that could reshape our understanding of physics. We're delighted to have this very talented author join us here today on Spotlight. We thank the team at Prime 7 Media for helping us put him in the spotlight today. And we ask viewers like you to support authors like him by subscribing to our channel and by purchasing his wonderful book. The links are below the interview. Les, thank you so much for joining me here today on Spotlight.
I'm very pleased to meet you and talk to you.
Pleased to meet you. Pleased to talk to you as well. This is a great book. It's a game changer when it comes to conventional wisdom. What inspired you to challenge widely accepted scientific principles?
Well, sir, I should tell you that I'm an engineer, really, not a scientist. And it seems a little out of place for me to be challenging the people who are supposed to define all of the laws of nature that the engineers live by. And I lived by them, and I think I was a pretty good engineer. But there were some things that they didn't quite include in my education, at least not to the degree that was satisfying. There were things we couldn't check in the laboratory, like the speed of light. There just isn't any easy tool for measuring that. We were to take what was given to us by the people who had studied it and presume that they were correct. There were other little mysteries, but light was the centerpiece of my problem. What set the speed of light? Why does it have a speed limit? If it has a speed limit, how come that governs the speed of everything else? Nothing can go faster than the speed of light. These things didn't make any sense to me. They never came up during any of my engineering because we dealt with the practical things of making equipment design well and work well and so on. And I enjoyed every day of my engineering career. But when I retired, I'm 95 years old now, so I have had a good deal of time being retired. You can think about whatever you want to when you don't have a job anymore. And one of the things that I thought about was some of these physics problems that weren't explained well enough to me. And I thought I would try and make them more understandable to myself. Now, the first book is about the expansion of the universe, which was introduced by Edwin Hubble in 1929, same year I was born. So I obviously didn't pay much attention to it for a while. But when I did, it had some inklings of the kind of truth I was looking for. Can I get into the technical details?
Absolutely.
Edwin Hubble was in charge of the Hooker telescope and the other activities that were being done to study the farthest reaches of the universe. And in 1929, same year I was born, he published a earth-shaking, rather universe-shaking paper that said they had, with the 100-inch Hooker telescope, seen galaxies that were hitherto out of reach, and discovered a very interesting thing about them, and that is that they were all moving away from the Earth. No matter which direction in the sky you looked, the far-off galaxies were getting farther away from us in that direction, whichever one it was. Up until then, people had pretty well assumed that the universe was static. It wasn't completely that way. There was one man a few years earlier named Georges Lemaitre, who was a minister, but he proposed that the universe had originally started as a single lump of matter and exploded into what has become our universe. He didn't have a mathematical basis for that or any data to support it. It was something that came out of his imagination. But Hubble came up with data that does support that. And Hubble's data said that all of the farthest away galaxies appear to be in a uniform kind of motion, and the direction of motion is away from us. And the velocity at which they're moving is directly proportional to how far away they are from us. It kind of suggests that we're the center of the universe, like the Greeks thought we were. But because there are literally millions of planets, it seemed unlikely that we would just happen to be at the very center. And there is another explanation for it, and that is that the universe is like a three-dimensional version of a child's balloon, where if you were to put dots on the surface of the balloon and blow it up, the dots would all move apart as the balloon gets larger, and they would move apart in direct proportion to the distance they are apart to start with. That's exactly what Hubble found out about the galaxies. They are all moving away from us, and the velocity away is proportional to the distance from us. And he wrote a very simple equation, which he modestly called Hubble's equation, that says that the velocity away from us divided by the radius is equal to a relatively fixed number, which he again modestly called Hubble's constant. The mathematics are that this is a picture of a sphere, just like our globe is a sphere, but in 3 dimensions rather than 2 dimensions like the surface of the sphere. And it suggests that the value of Hubble's constants, which was kind of disguised by the astronomers, he gave it in megapixels per kilometer of distance as a velocity. But it turns out that ratio is actually equal to time. The time the universe has been in existence, which is placed at somewhere around, I calculated back in 1910, at 13.7, I think, million light years. Big distance.
Yeah.
They argue about it still considerably, and I think 17 is a more popular number now. But that is actually the age of the Earth in seconds is equal to Hubble's constant. The important thing is that the velocity is the primary variable, and the velocity is they use the letter C for it, the same as the one used for light. But the expansion of the universe has nothing whatever to do with light. It would be taking place if the stars didn't give off light. It is the speed, basically, of time. It's the rate at which matter is expanding out of the 3-dimensional universe we live in into the future. It's not the velocity of light, it's the velocity of time. But it has an interesting relationship with time, because if you want to specify a distance, you usually specify it in distance units. something is 100 miles away. Or you could say it's an hour and a half away by car at 60 miles an hour, 63 miles an hour. You can use time units and distance units interchangeably to describe either time or distance. And the conversion factor for those units just happens to be exactly C. And the reason it's exactly C is that that's defined by the US Bureau of Standards as the ratio of the meter to the kilogram, or the meter to the second. So it is something that has an exact number, but it's so easy to mistake the velocity of time for the velocity of light, because they both have direction. They both are measured in either time or distance units. And that gave me the first little bit of support to the idea that I might be able to figure out why light actually has a velocity and what the velocity is, and why it is not what Einstein thought it was. That's about as far as I got with the new light on the expanding universe. It shed a new light on a whole bunch of things. It didn't tell me what the velocity of light actually was. It told me what it wasn't. Okay, the question of what it was a little easier to work out, actually, because even Einstein agreed that at the present moment, if everybody in the world had an accurate clock that were all set to read the correct time, they'd all read exactly the same time. That it's the same time everywhere right now at this moment, but only at this moment. And this posed a problem for Einstein in that he had written some equations for light going from point A to point B along a straight line. And if it was going in the same direction that the point was moving, you would expect the light to get there earlier than if it was standing still. But if you were on the other side of that picture, you would expect the light to get there later, because the light and the distance are going opposite directions now. That didn't work. So Einstein used, I would call it a sort of cut-rate solution to the problem. Not a good one. He adopted the transform that was being used by one of his scientists at the moment that involved what happens when you rotate a vector quantity. It's got direction. And when you rotate it, it's the same as taking assigning an angle to the rotation. And one side of the triangle you get is the original length. A shorter one is a component in a second direction, and the third is the little bit of difference between the two. He used that, and it was a complete misuse, because it led him to believe that time got shorter for things that are moving faster. There's no relationship there at all. And it is because time actually moves essentially instantaneously. Light is only transferred during a particular moment in time. It doesn't go outside. Light doesn't ever get there before it left or after it left. It's there at exactly the same time it left the source, which got, I think, into the second book that the speed of light really is essentially infinite, or such a large number that we'll never measure it, much faster than time moves. There's a long lapse in between that and a third book where my thinking had progressed a bit. And I had figured that Einstein really is just completely wrong about everything in special relativity. That all of the correction factors that say that matter gets heavier when it's moving faster, is absolutely silly idea. But it comes from the mathematics that he used incorrectly. It says that as something is moving, the time on it gets compressed. You know, that the astronaut moving at high speed doesn't age as fast as one who's standing still. We have twins going on a spaceship and coming back, and he's only half the age of his twin brother who stayed on Earth. It's ridiculous and wrong.
Exactly.
I have continued doing that sort of thing, and I'm working on a fourth book, which has got just about everything that I've got figured out that I think these people have done incorrectly. And I don't think they did anything incorrectly on purpose, but it pointed out to me that the people who measured the speed of light did it the same way I was taught to do physics experiments in college. That is, I knew what the answer was going to be. I wasn't trying to find it. I was trying to do the experiment and get it exact.
Exactly. And that's the problem with science is we stand on each other's shoulders and there's this
Well,
accepted wisdom and accepted knowledge, right?
right, but even if you think you have an open mind, if you set out to measure something and you set up an experiment very carefully and do it very carefully, and you get a number, you figure that's what you set out to measure.
Right.
And you don't look to see if there wasn't another way you could explain the same thing.
Exactly.
And so the Michelson, who was the first one to really get a good measurement of the speed of light that Einstein used and took as gospel, he didn't measure the speed of light, he measured the speed of time.
It's amazing. All of
So,
this is just absolutely fascinating. It's in your books. We're out of time. We could talk all day about this because it truly is groundbreaking and it truly is fascinating. The book we've been focused primarily on today is called A New Light on the Expanding Universe. It is a groundbreaking book. You've heard some of the groundbreaking counter theories that challenge long-standing scientific theories, proposing a bold rethinking of Einstein's concepts of light, relativity, and the nature of the universe's expansion. Wonderful work here, wonderful insight, Les. Thank you so much for joining me here today on Spotlight.
I enjoyed it. Thank you.
I enjoyed talking to you as well. I found it fascinating. To the folks at home, I'm Logan Crawford, thanking you for your time this time. Until next time on Spotlight.